In this video, we're going to look at the relationship between three different forms of quadratic equations and the graphs of parabolas. Okay, so three different forms that you can look forward to. In your notes, once you go ahead and write down quadratic functions and parabolas. Okay, so the first form that we've actually worked with already this year is y equals ax squared plus bx plus c. A, b, and c are called coefficients. This is the general form. The second form is y equals a times x minus r1 times x minus r2. This all should be familiar to you from Algebra 2, so we're just kind of reviewing here. If you take the general form and then you factor it, you might get this, right? X minus something times x plus something, maybe. And because we factored, we call this the factored form. And the last form we're going to look at is this one right here, y equals a times x minus h squared plus k. So this form utilizes what may be the most important part of a parabola, which is the vertex. H and k are the coordinates of the vertex. We call this the vertex form. All of these forms can be useful in different cases, and we're going to practice using them over the next day or so. I want you to write down R1 and R2 are roots. That's where the R comes from. And remember, we also call them zeros. The reason we call them zeros is because if you plug in a value for R1, so it might be like x minus 2 times x plus 3. If you plug in the value of R1, then it'd be R1 minus R1 is 0, so it'll make the function 0. And because it makes the function 0, we call it a 0. And you'll remember that HK is the vertex. So if at any point I'm going too fast for you here, feel free to pause. It won't hurt my feelings at all. And then you can continue when you're ready to go again. All right, so let's take this away. Let's look at a particular equation. Y equals x squared minus 6x plus 5. Okay, so nice small whole number coefficients. If we want to graph this, one thing that's going to be really helpful for us is to get it in factored form. Right, so we know we have an x here and an x here. If we're factoring this one should be pretty easy to factor. We want two numbers that are going to go here and here that multiply to 5 and add up to negative 6. And those numbers are negative 1 and negative 5. If you were to multiply this out, use distributive property, you would get this right here. Now, if we want to find, so I want to graph this. And one thing that's going to be helpful is to find x-intercepts. Remember, to find x-intercepts, you set the y equal to 0, because where y is 0, that'll be your x-intercepts. So we'll set y equal to 0. And then we have this right here, and we're going to use the zero product property, which says that if you have two things multiplied together that equal 0, then one of them must be 0. Okay, so x minus 1 must be 0 or x minus 5 must be 0. So we can solve that for x equals 1 and x equals 5. Let's go ahead and write down our x-intercepts. Our x-intercepts are going to be at 1, 0 and 5, 0. Remember, x-intercepts are a point, so you should actually have the coordinates, x and y coordinates. Another point that's going to be helpful for us is the y-intercept. The y-intercept is going to be at the point where x equals 0. So if you go up to your original one here, if you set x equal to 0, then all you'll have left is 5. So the y-intercept is at 0, 5. So let's go ahead and graph what we have so far. Let's see here. Now, I know that because my x-intercepts are positive and my y-intercept is positive, most of this graph that we're going to do is in the first quadrant. So we can make our axes like this. I have a y-axis there, an x-axis there. Y-intercept is 5, we've got an x-intercept of 5. So let's use the same scale on this, kind of eyeball this here. If that's 5, that'd be 1, maybe about there. And so what we have is 3 points so far. We have a couple x-intercepts and a y-intercept. And we could make a parabola using these, but we want to be a little more accurate. So what I want to look at is we could get a line of symmetry here. And we know our line of symmetry is going to be halfway between our x-intercepts at 3. So that's going to be helpful. I want to take a step back though and look at what would happen if we weren't able to factor this formula. So let's set y equal to 0 here, and let's make this x squared minus 6x plus 5. Okay, so we were able to factor this one, but if we weren't able to do that, then what we would want to do is use the quadratic formula. Make sure you got 0 here, and then we could use the quadratic formula, which is this: x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, I don't know if you've seen this before, but you can actually write the quadratic formula in a slightly different form, which is negative b over 2a plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so equivalent formula there. Break it up into 2 different fractions. Remember, if you wanted to add these 2 fractions, if you have a common denominator there, you could put the common denominator there and then add the 2 numerators and you'd be fine. So this is actually helpful for us because what we can do is utilize in this form and see something pretty cool. So we're going to plug in our a, b, and c. A here is 1, b is negative 6, c is 5. So we take the opposite of b. B is negative 6. So the opposite of that would be positive 6. We have 2 times a. A is 1, so that'll just be 2. Plus or minus the square root of b squared. B is negative 6. Negative 6 squared is 36. Minus 4 times a times c. A is 1. C is 5. 4 times 5 is 20. And we divide by 2. So what do we have here? 6 divided by 2 is 3, plus or minus the square root of 36 minus 20 is 16. The square root of 16 is 4. And 4 divided by 2 is 2. Right? So normally I'd show a little more work, but I'm running out of space here. So we'll just put it there. 3 plus or minus 2. So 3 plus 2 is 5. Or 3 minus 2 is 1. Now, this actually agrees with what we had up here. Right, we had 1 and 5, but the nice thing here is that what shows up here is the line of symmetry, that 3 right there, shows up right there. And that's always going to be the case. See, I have the 3 and then plus or minus 2. Let's see, make sure we recognize why we're always going to have this, which actually comes from right here, show up as our line of symmetry. You have the 3, plus 2 will give you 5, minus 2 will give you 1. So that's always your y-intercept. We can write it down here. X equals negative b over 2a is the line of symmetry. Always going to happen. And since we know that hk is the vertex, and we know our vertex is on the line of symmetry somewhere, then our vertex must have that as its x-coordinate. So we can say h equals negative b over 2a. Very important to remember that. You want to memorize that if you haven't seen this already. H equals negative b over 2a, which in this case would be negative opposite of 6. I guess we did that already. 2a equals 3. Now, how do you find k? The other part of our vertex. Well, k is the y value that is associated with this x value. So you can take k, substitute into your original equation here. Since h is 3, it'll be 3 squared minus 6 times 3 plus 5. And k is going to be, I'm playing with the lights here, sorry. 9 minus 18 plus 5 is a negative 4. So the vertex is at 3, negative 4. So we can plot that final point. Well, actually, maybe not the final point. Let's see, be -4 would be maybe down about there. Got a point there. Make this one blue, maybe. The coordinates are 3, -4. There is one other free point we can get, which is I call the symmetric point. And since we know this is from the y-intercept over here is 1, so if we go over 1 more to 6, then we'll go up to 5. We're going to have a point there. It's kind of real easy one to get, and that'll help us get a nice looking parabola. Let's see how we do here. So with those 5 points, we can sketch our parabola. And there we are. Okay? And if you don't quite hit that point, just make it a little bit fatter. There you go. And you got it. Put a couple arrowheads here. So this is our 3 formulas we have. The general form, the factored form, the vertex form, and simply how they relate to our parabolas. What we're going to do next is look at how we can take a parabola and then find the quadratic equation, the quadratic equation for that parabola. We'll do that next.